So in this question, we have one piece, an object that suddenly breaks apart into two, moving in opposite directions. So let's just call this one A and this one B. One object, one fragment has twice the kinetic energy of the other. Let's just assume A is the one that has larger kinetic energy. So this question, since we are not given any numbers, we are really just trying to work with the equations. So we have conservation of momentum as usual. So we have 0 before the collision and MAVA plus MBVB after the collision. That's pretty much the only conservation law we can use, because we can see the kinetic energy is definitely not conserved, because it was 0 and then all of a sudden it becomes non-zero. But the reason kinetic energy is not conserved is because the reason it breaks apart, there is an explosion. There must be some chemical energy stored inside this object that causes it to explode, and that chemical energy is being transferred into kinetic energy. But although we do not know that we do not have conservation of energy, we still know that the kinetic energy of A is twice the kinetic energy of B. So that means the kinetic energy of A is twice the kinetic energy of V. Great. That's the two equations we have. And from these two equations, we are trying to find the ratio of the two mass. And so how do we find MA over MB? Usually, we can only find the ratio if we have one equation involving only MA and MB, meaning we need to get rid of both VA and VB. And we can do that by, let's first try to do it step by step. Let's first try to cancel all the VB in this equation. And this one seems more straightforward, so let's start from this. And we try to express VB in terms of other quantities so that we can get rid of VB. So this is if I rearrange the first equation, I get expression of VB. Then if I plug that into the second equation, we have MAVA squared over 2 equals MBVB squared, where VB is this number. And I ignore the negative sign because there is a square that will change or negative into positive. And if I simplify this a little bit, I get MA squared VA squared over MB. That is great, because if now you look at this equation, you find VA squared on both sides. So VA squared also cancels. That leaves us with MA over 2 equals MA squared over MB. Or if again we divide both sides by MA, gives us MA over MB equals 1/2. So that is what we're trying to know. So the fragments with larger kinetic energy is half the mass of the other fragment.